Continuing with this example, I want to add one note here. Let's go ahead and fill in the x-intercepts and the y-intercepts in the blanks. So we have here that the y-intercept is 0, 9, and we have two x-intercepts at -9, 0, and at -1, 0. If we look back at the original function, it's interesting that we could have obtained the very same graph by thinking about transformations. So if you think of the parent function as being the square function, y equals x squared, it's as if we had translated it 5 units to the left and 16 units down. And that is indeed the case. So there's alternate ways to obtain this graph, either by thinking about transformations on the parent function or by looking at the anatomy of the quadratic graph by finding the vertex, the axis of symmetry, and then the x and the y intercepts. Let's work out a similar example. Here we have f of x is equal to the opposite of x plus 2 quantity squared minus 4. Again, I want to write this in terms of what A, H, and K stand for. So I'm going to write this as -1 times x minus a -2 quantity squared plus a -4. Here we have that, make this a little larger. We have that A is a -1. We have that H is a -2. And K is a -4. That means that our vertex is at the ordered pair -2, -4. In this case, the axis of symmetry is the vertical line x equals -2. Because A is negative this time, the parabola will open down. Let's go ahead and add this information for now. The vertex is at -2, -4. The axis of symmetry, which I'm going to add as a green dashed vertical line, is our mirror. This is our line of reflection. And we know that the graph is going to open down. Let's solve for the x and the y intercepts algebraically like we did in the last example. First, let's set y equal to 0. So if y is equal to 0, we have 0 equals negative x plus 2 quantity squared minus 4. Adding 4 to both sides, we get that 4 is equal to negative x plus 2 quantity squared. And if we multiply both sides by -1, we get that -4 is equal to x plus 2 quantity squared. Now using the square root property, we get that x plus 2 must equal plus or minus the square root of -4. And we pause and see that we have an issue. -4 does not have a real square root. It does have an imaginary square root, but imaginary square roots have no place on the xy plane. So we can say here that there will be no real x-intercepts. And that should make sense. Look at where the vertex is on the graph, and we're going to be opening up the parabola down from there. So no part of the graph will cross the x-axis. Therefore, what we obtained algebraically matches what we understand conceptually about this graph. Next, let's look at the y-intercept. This time we're going to set x equal to 0 and solve for y. So we have y equals the opposite of 0 plus 2 quantity squared minus 4. So y will equal the opposite of 4 minus 4, or -8. That means that 0, -8 will be our y-intercept. Let's go ahead and add that to the graph. And then using symmetry, remember this green vertical dashed line is our mirror. We can say that we'll have a reflection right there where I just added the point. So this is enough for us to get a sense of the shape of the graph. And again, we see that this graph will not cross over the x-axis at all, which explains why we have no x-intercept, at least no real x-intercept. The domain for this quadratic function, as is the case with all quadratics, is the set of all real numbers. And here we see that the highest y value is a -8, but that there is no lowest y value. That means that the range will go from -infinity up to and including -8. Again, if we think about transformations and we think about the parent function being the square function, y equals x squared, I see three transformations. I see a horizontal shift 2 units to the left. I see a vertical shift 4 units down. And then I also see a reflection that is vertical across the x-axis. So the graph that we have here could also have been obtained by those three transformations. So we have 2 left, 4 down, and a reflection over the x-axis. Let's look at another example. This time we have f of x is equal to -2 times x plus 3 quantity squared plus 2. By now, you should fall into the habit of identifying the values of a, h, and k. In this case, a is -2. H is a -3 because we're subtracting a -3 to obtain that addition. And K is +2. That means that our vertex is at the ordered pair -3, 2. Our axis of symmetry will be the vertical line x equals -3. Because A is negative, the parabola will be opening down. Let's add this information to the graph. The vertex is at -3, 2. The axis of symmetry, which I'm going to add as a dashed vertical line, is right here going through the vertex. Next, let's solve for the x and the y intercepts algebraically. We're going to set y equal to 0 and solve for x. So we have 0 equals -2 times x plus 3 quantity squared plus 2. We can add the first term to both sides to get 2 times x plus 3 quantity squared equals 2. Then divide both sides by 2 to get that x plus 3 quantity squared is equal to 1. Using the square root property, we find that x plus 3 must equal plus or minus the square root of 1, or x plus 3 is equal to plus or minus 1. Subtracting 3 from both sides, we get that x is equal to -3 plus or minus 1, which gives us that either x is equal to -2 or that x is equal to -4. That means we have two x-intercepts at -2, 0 and at -4, 0. Let's solve for the y-intercept now. We're going to set x equal to 0 and solve for y. So we have y equals -2 times 0 plus 3 quantity squared plus 2. Y is equal to -2 times 9 plus 2, or y equals -18 plus 2, which gives us -16. That means that we have one y-intercept at 0, -16. Let's go ahead and add these 3 points to the graph. We have -2, 0, and -4, 0. And then we have 0, -16. And then by using a reflection, the fact that we have symmetry, we can add a point right over here on the other side of that axis of symmetry. So this gives us enough information to get a good idea of the shape of this parabola. The domain, as always, with quadratic functions is the set of all real numbers. And the range goes from -infinity up to the highest observed value of y, which is a +2, and that is included. Again, if we think about transformations on the parent function, I see 3 transformations. I see a horizontal shift 3 units to the left. I see a vertical shift 2 units up. And then I see actually 4 transformations because I also see a vertical reflection across the x-axis because of the negative sign. And I also see some stretching because we're multiplying by a real number other than 1. So 4 transformations here: a horizontal translation, a vertical translation, a reflection, and also a stretch.